All right. So, welcome to our 14th lesson for probability and statistics, and it's called binomial distribution. So, bi, the prefix bi usually means two. We use binomial distribution when you have like two choices, like true or, that's supposed to be or false, pass or fail, zero or one. We did a problem with like a hit or a miss. So, anytime that you can have like two situations, raining or not raining, okay? All right. So, instead of us memorizing a really long formula or whatever else, I always try to teach you all how to use calculators for things. So there is a function in the calculator called binom. And there's actually two of them. So one of them is called binom PDF. And this is when you are looking for exactly something to happen, right? So we'll go through a situation in a second. But whenever you see the word exactly, that's the only time you're going to use binom PDF. Okay. PE is the way I remember it. Okay. Every other time, you're going to use something called binom CDF. And this is when you have a situation that's greater than or less than or greater than or equal to or less than or equal to, right? Anything else besides just straight up equals. All right. And we'll go through a problem to make sure that you are solid on this beforehand. I want to go through a couple of notations. So P represents the probability of success, right? If it's getting a hit on a target, then the probability of getting that hit. N represent how many times you're taking shots or how many trials you're going to be doing, how many times you repeat the experiment. And R is the number of successes that you could have. Okay. So this over here goes through just how you plug it into the calculator. So binom PDF, again, this is whenever you have exactly R. So if I said find out that Miguel hits a target, let's just say, and he takes 12 shots, and his probability of success is 0.4. And if I said find out what's the probability that he will hit exactly 4 shots, how we plug this into the calculator is we do binom PDF. I'm going to write this down first. And then let's go ahead and do this. So where's binom PDF in the calculator? Let me start that up again. Sorry, my bad. And again, you should be doing this on your calculator with you. If you hit second vars, okay, second vars, we're going to go all the way down to the bottom. I just hit the up arrow and I'm looking for binom PDF, which is choice A. So I'm going to hit enter. So then it asks you the number of trials, right? So how many times is he shooting this target? So there are 12 trials. The P is the probability of success. So he hits the target 0.4, 40% of the time. The X value, right? This is what we're looking for. This is exactly 4. So we're going to put a 4 here. Okay. And then you hit enter until you get an answer. Do you see what it does? Binom PDF. This is you showing your work, right? Binom PDF. So we're going to put 12, comma, 0.4, comma, 4. And then you hit enter in the calculator and it gives you an answer. So boom, 0.213. So 0.213. Okay. So that's an example of how you use binom PDF. And again, PDF is whenever you have the word exactly. Okay. You're looking for exactly that. Now, when do you use binom CDF? Any other time, right? So for example, if we said that Miguel, same situation, right? There are 12 shots that Miguel takes. Probability of success is still 0.4, but we want to find out the probability of getting up to 3, right? Up to 3. So that means the probability of 0 shots plus the probability of 1 plus the probability of 2 plus the probability of 3, because up to means up to and including. Okay. So instead of us having to do binom PDF 1, 2, 3, 4 times and then adding them up, there is a shortcut. And so the shortcut is this, right? So you do binom CDF, okay? And then you're still going to do the number of trials, 12, comma. The probability of success is still 0.4. And now, what number are we counting up until, right? We're counting up till 3, okay? So this, like if I want to look at this, this is going to be less than or equal to 3, okay, is what we're looking for. So perfect. So then now let's go ahead and plug this into our calculator. So we're going to hit second vars again, right? Think of vars like varghese. Option number, now look, binom CDF, right, is letter B. So we have to hit that. And then again, it asks us the number of trials, still 12, right? Probability of success, he still has a 0.4 chance of hitting the target. And then now we're putting 3. So instead of us having to manually figure out the probability of 0 plus the probability of what, like binom PDF, then putting 0, then 1, then 2, then 3, and adding it up, you just hit enter, 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 and it gives you 0.225, right? So the probability of him hitting up to 3 shots, or at most 3 shots, is 0.22, what did I say, 5, right? Is that correct? Yeah, good memory. Okay, all right. So we just went through a couple of situations. There is a table here. I am going to encourage you to take this and put this into your OneNote or put this into your notebook, flashcards, wherever it is that you have to help you remember this. And you're going to need to study this at some point. If there's anything that you have questions about, just refer back to this, okay? All right, so we're going to go through and do a couple of problems. So assuming the birth of boys and girls, right? So again, there's only 2 situations, boys and girls, right? Are equally likely in this case right here, right? Calculate the probability that in a family with 6 children, all of the children are girls. So now we have to take a look and see what do we have, right? So the number of trials, let's see, right? The number of trials, it says in a family with 6 children, so that's going to be 6. The probability of success, right? So it says all of the children are girls, so our P, right? What is our chance of getting girls? If it's boys and girls, the probability is going to be 0.5 or 1/2. Perfect. And it says all of the children are girls, so that we have exactly, right? That's inferred, exactly 6 girls. So we know how to do this, right? Whenever we have exactly, you're looking for all of them being girls. We're going to hit second vars and we're going to do binom PDF, right? Because we're looking for exactly that amount, not up to that amount, exactly, not greater than or less than, or greater than or equal to or less than. So let's go ahead and put this in. So 6, enter, 0.5 or 0.5, enter, and we're hitting exactly 6. So you hit enter, and then our answer, right? So 0.015625. So here's me showing work, right? Binom, PDF, trials, 6, probability of success, 0.5, exactly 6, hit enter, and this is about, let's go back to our calculator, we have 0.016, 0.016, okay? So that is our answer for the first part. All right, so we do need to know that 0.016 is the same thing as 1.6%, right? We know that, right? Multiply by 100, so you could put it as a percent, which makes sense, right? It's very highly unlikely to, in a family, to get of 6 children, to get 6 girls, exactly 6 girls. So 1.6% chance completely makes sense. All right. So next, we have same family, 6 children. There are up to 4 girls. So let's talk about what that means, right? So probability of 0 plus probability of 1 plus probability of 2 plus probability of 3, right? Plus the probability of 4, right? So up to 4 girls, that's what we're looking for. So you, like I said, you could do binom PDF 1, 2, 3, 4, 5 times and then add them all up. But the easier way is to use binom CDF, right? Binom CDF. Okay. So the number of trials, again, is 6. Probability of success of getting a girl is 0.5. Just like that's the probability of getting a boy in this case. And we have up to 4. So we're going to put a 4 here. And now let's take our calculator and put this in, right? So we have second vars again. We're going to go binom CDF, so that's option B this time. Probability, the number of trials is 6. The probability of success is 0.5 or 0.5, and then we are looking for up to 4. Beautiful. Okay, so now we hit enter, and we get 0.891. Okay, so this is about 0.891, right? Or 89%. Okay, that's a pretty high probability. Okay, all right. So this last one right here can be tricky, which is why I put this in. So there are more than 2 girls. So let's talk about this real quick. So this is probability of 0 plus probability of 1. I'm just going to write down all the probabilities, right? Plus probability of 2 girls, plus probability of 3 girls, plus probability of 4 girls, plus the probability of 5 girls, plus the probability of 6 girls. Okay. Okay, so there are more than 2 girls. So let's talk about what this means, right? That means that we have, this is what we want, right? More than 2 is 3 girls, 4 girls, 5, or 6 girls, okay? This is what we want, okay? So we know that our calculator, when we use our calculator for binom CDF, that can give us this part over here, right? That can give us this. So we can get this by doing binom CDF. Right? So binom CDF, we can go 6 trials. Probability of a girl is still 0.5. And we can go up to 2. See this right here? So we're going to stop at 2. So we're going to put a 2 here. Okay? That's going to give us this amount right here. Remember when we did probability distribution, right? The total is going to equal 1 whole. Like if you take all of these and add them up all together, that's going to equal 1. Okay? All right. So let's find out what this is. Let's take our calculator, second vars, right? Let's go to binom CDF. I know this video might be a little bit longer, but I want to make sure that you understand it. Still 6, still 0.5, and now here we're going up to 2. So we're going to hit enter and enter and enter. Okay, so 0.344, okay? So 0.344. Now we want, that's a 4. We want the remaining, right? So we want to do 1 minus binom CDF. See what we're doing? 6, comma, 0.5, comma, 2. Okay? This is what we really want. So let's go ahead and take our calculator because we want to try to get back to this little spot, right? This is what we want, this whole remaining part. So the whole thing is equal to 1 minus the part that is just up until 2. So that's 1 minus binom CDF. So let's do it. So you could just do that straight into the calculator, 1 minus, and then now I'm going to go up and grab this. Hit enter, and I get 0.656. Okay, so the final answer is 0.656, which is about like almost 67%. That's the probability that there are more than 2 girls, and that should make sense. Okay. I want to go back because I did skip it. This here can also help you, or that table at the top. There are 2 other formulas which we're not going to talk right now about, but this is in your formula booklet. So the mean of a binomial distribution, the formula for that is E of x is equal to NP. We did that similar to last time. And the variance, right? So this is going to be var of x is equal to NP. And again, you don't need to memorize this, 1 minus p, okay? Just 2 formulas that are in your formula booklet. And we will at some point go through problems like that, but I want to make sure that you understood the actual lesson, which is right here. There are a couple of problems. There's this one for you to do for example 2. So I'm going to pause the video and ask you to try it, and I'll put the answers down for you, okay? All right, so hopefully at this point you looked at it, you're trying it. So the first thing we want to do is we want to read through the question and see what is our, the big things that we need to take away. So what is our N, what is our P, and what is our R? So this is going to be dependent on the question, okay? So how many times are we playing this game? We are playing this game 10 times. So n is 10. Our probability of success, right? It says we will win if we select a black one, a black ball. So there is one black out of 5 altogether. So this is 0.2. Okay. So now we can go ahead and look, right? It says exactly 4 times that we get 4 black ball in a row. So what we're going to do is we're going to do binom. Anytime it says exactly, we're going to do binom PDF. The number of trials, our n is 10. Our probability of success is 0.2 or 1/5. You can put either one down. And then our r, right, the number that comes after the word exactly is 4. So I'm going to take this and I'm going to put it into my calculator. Okay. So right there, 0.088 is what we should have. So this is 0.088 is our answer for the first one. All right. Cool. So I'm going to ask you if you can to go ahead and try the next one. So the probability to win at most 4 times. So when it says at most 4, that means that we are going to have less than or equal to 4, right? That's what at most means. So we know at this point we are going to do a binom CDF. So I'm going to give you a chance to go ahead and set that up. All right, so we have binom CDF. Still 10 trials, probability success is still 0.2. And at most 4. Okay, so we're going to put a 4 here, close those parentheses, plug that into our calculator, and we get 0.967. So 0.967. You could change that to a percent. Just trying to answer the questions and keep it moving. Okay, so we did A, we did B. All right, next thing we're going to do is C. So pause it, try it. Okay, so this one can be tricky, right? At least once. That's why I left you the rules at the top. So at least is going to be greater than or equal to 1. So how you do this is 1 minus binom CDF, still 10 trials, still probability of success is 0.2. And then at least 1, right? We have to take this number and subtract 1 from it, which is 0. And then if you're like, wait, what? How are you doing that, right? If you look back up over here, at least means that we're going to be doing this right here, right? So think complement, right? So it's going to be 1 minus, right, binom CDF. And then if you have at least 5, you're going to take 1 minus this 5 and put a 4 here for the 1 minus binom CDF, right? So you have to subtract 1 from the number for the R. So let's go back over here, and 1 minus 1 is going to be 0. That's where I'm getting that from. And if we take this and we plug this into our calculator, we're going to get 0.893. So this is about 0.893 is our answer for at least 1. Okay. All right. The expected number of winning games. So remember when we wrote down the two formulas for expected? So expected formula is E of x, which means the expected value of x, and that's going to equal n times p. Okay, so our n, right, is 10. So we're going to do 10 times our p. Our probability of success is 0.2. So this is a straight calculator question, and this answer is just 2. Okay, so 2 is our answer for letter D. So boom, boom. And then the variance. Okay, so the variance, the formula for variance of x is going to equal np times 1 minus p. Okay, so this is just plugging things in. So our n is 10 again. Our p is 2, so 0.2. Our p is 0.2, my bad. And then our 1 minus p, so 1 minus our p again is 0.2. You plug all of this into the calculator, you hit enter, and you're going to get 1.6 as your answer. Okay, all right, so that is letter E. So that was example 2. I'm going to ask you if you can to try these problems that are here. Check your answers. This was a little bit of a longer video, but I did want to make sure that I explained it. All right, good job.